Okay, so this is the key to topic 21, part C, radicals extra 11. And if you look at the worksheet, so notice that on this worksheet, you're adding, subtracting square roots in some problems. In some problems, you have cube roots. It does say show all necessary work to receive credit for correct answers. So just don't write the answer. You got to show the work. Notice the word work here. Okay, so let's look at number one. Okay, so number one, you have these three terms that you're adding or subtracting. Now remember, when adding or subtracting radicals, you can only combine like terms. And before we can talk about combining like terms, you have to make sure that all of these, in this case square roots, all these square root expressions are simplified, and then you look to see which ones are like terms. So let's do the work on the side to simplify each of these square roots. So let's do the first one. So the first one, you have the square root of 50x squared. And from previous experiences, from previous lessons, we know we can write this as a product, square root of 50 times the square root of x squared. And I can simplify the square root of 50 because 25 is the largest perfect square that goes into 50. So I can write the square root of 25 times the square root of 2. 25 times 2 is 50. And I know right here that the square root of x squared, that's just x, because x times x is x squared. And the square root of 25 is 5, so I get 5 square root of 2 times x, and I'm going to rewrite this by placing the square root of 2 at the end of the expression. So this becomes 5 square root of 2 times x. I'm sorry, I said I put the square root of 2 at the end, so 5x square root of 2. Okay? And so that's this right here. So, but don't forget though, this is being multiplied by 7. So you're going to say 7 times 5x square root of 2. So that's the work you're going to show right here. Minus, and then you do the same thing for the other one. Okay, so let's do the next one. So I have the square root of 18x squared. So using that same idea, that's going to be the square root of 18 times the square root of x squared. I know that the square root of 18 I can simplify. So that 9 is a perfect square that goes into 18. So the square root of 9 times the square root of 2. And the square root of x squared is just x, because x times x is x squared. And the square root of 9 is 3. So you get 3 square root of 2 times x. And I'm going to rewrite this just like I did the previous one. So it'll be 3x square root of 2. Now don't forget, that's just this part here. So you remember you multiply it by 8. So you get 8 times 3x square root of 2. And then we do the next one. So the next one, I'm going to go ahead and do that here. So the next one, I have the square root of 32x squared, right? And so I can rewrite this as the square root of 32 times the square root of x squared. The largest perfect square that goes into 32 is 16. So I can rewrite this as the square root of 16 times the square root of 2. And the square root of x squared is x. The square root of 16 is 4. So simplifying that further, and then rewriting this, I get 4x square root of 2. And that's going to go here. But don't forget, that's being multiplied by 3. So you get to subtract 3 times 4x square root of 2. All right, so based on all this information, this is what I have. Now I'm going to rewrite, I'm going to simplify each term now. 7 times 5 is 35, so I get 35x square root of 2. 8 times 3 is 24, so you get minus 24x square root of 2. 3 times 4 is 12, so you get minus 12x square root of 2. Okay? Now, let's talk about whether these are like terms. So remember, when working with radicals, in order for terms to be considered like terms, you have to have the same radical. So meaning the same index and the same radicand. So if you just look at the square root of 2, there's a square root of 2 in all of these terms. But in addition to that, outside of that radical, you see that extra factor of x. So now you have to consider this as 1. So this expression here, x squared of 2, has to be in all of them for all three to be considered like terms. All right. So I have 35 of these, a negative 24 of these, and a negative 12 of these. Okay. So 35, and use your calculator if you need to, 35 and a negative 24. So 35 and a negative 24, x squared of 2 gives us 11. right? 11x squared root of 2. And 11x squared root of 2 and a negative 12x squared root of 2 is a negative 1x squared root of 2. So negative x squared root of 2. So that's the answer. All right? So there's your work. There's the answer. All right? Let's look at number 2. So I'm going to go ahead and use another sheet of paper since I used up all the room for this. So here's number 2. So number 2, we have this problem. All right, so number 2, we have the cube root of 16y minus the cube root of 128y. Okay? All right, so let's talk about that. Well, let's go off to the side and kind of figure out what the cube root of 16y is. So by the product property, I can rewrite this as a cube root of 16 times a cube root of y. Now remember, you're dealing with cube root now, so you got to think about what's the largest perfect cube that goes into 16, and that's 8. So I can rewrite this as a cube root of 8 times a cube root of 2 times the cube, that's supposed to be cube root here, times the cube root of y. And simplifying what I can, the cube root of 8 is 2, so get 2. And I cannot simplify these any further. But I know that there's a product property that says if the indices are the same, I can write this as one radical. So this is going to be the cube root, and I can do that by just multiplying the radicands together. So it'll be the cube root of 2y. So that part right here goes here. So that's 2 cube root of 2y. Minus, and then I do the same thing here. So let's go ahead and do that one. So for that one, I have the cube root of 128 times the cube root of y. Okay? So let's kind of determine the largest perfect cube that goes in 128. So you may say, well, let's try 8 again, right? All right, so let's say 128 divided by 8. I get 16. But is 8 the largest? So think of another perfect cube that goes into 16. Doesn't 8 go into 16 as well? So 8 times 8 is 64. So 64 should be the largest perfect cube that goes into 128. And so let's just check. 128 divided by 64, and you get 2. And so remember, 4 raised to the third power is 64. So the cube root of 64 is 4. All right, so let's go and rewrite this as the cube root of 64 times the cube root of 2 times the cube root of y. And the cube root of 64 we know is 4. So 4. And then I can rewrite the cube root of 2 times the cube root of y as the cube root of 2y. And that part goes here. So that's 4 cube root of 2y. And now notice those are like terms because the indices are the same and the radicands are the same and there's no extra variables involved. And so you have 2 and a negative 4, so that's a negative 2 cube root of 2y. Okay, so that was number 2. All right, let's do number 3. Number 3, you have 5 times the cube root of 125x plus 4 times the cube root of 8x. All right, so let's simplify each of these cube roots. So let me go off to the side and kind of do that. So the cube root of 125x is a cube root of 125 times the cube root of x, right? And then let's think about the largest perfect cube that goes into 125. Well, I mean, you could, if you want to, just take the cube root of 125 and see what happens. So watch, 3 cube root of 125, you get 5, right? So that means that 125 is a perfect cube, and that's just 5. So this becomes 5, and I cannot simplify the cube root of x. So remember, you cannot simplify the cube root of x because the exponent 1 is less than the index 3. So that's 5, but then don't forget, you're multiplying that by 5. So this becomes 5 times 5 cube root of x. This right here is this. Now let's do the cube root of 8x. So the cube root of 8x is a cube root of 8 times the cube root of x. Well, 8's a perfect cube, so that's just 2. 2 cube root of x, right? So that is this. So that's plus 4 times 2 cube root of x. Simplifying each part, 5 times 5 is 25, so you get 25 cube root of x. 4 times 2 is 8, so you get 8 cube root of x. And then notice that those are like terms because you have a cube root of x. The indices are the same, the radicands are the same. So 25 cube root of x's plus another 8 cube root of x's, and that gives us, what's that, 25 plus 8 is going to give us 33. So you get 33 cube root of x. All right. And then finally, number 4. So here's number 4. So number 4, you have the cube root of 32 xy cubed plus y times the cube root of 108 x. All right. So let's look at this. I'm going to go ahead and rewrite this right here. All right. So I have the cube root of 32 times the cube root of x times the cube root of y cubed, right? Okay, so let's simplify. See, that is this, using a product property. So let's talk about the cube root of 32. So I know that 8 is a perfect cube that goes into 32, and it is going to be the largest. So I can rewrite the cube root of 32 as the cube root of 8 times the cube root of 4. 8 times 4 is 32. I cannot simplify the cube root of x, so I'm going to rewrite it over. But I can simplify the cube root of y cubed, because y is divisible by 3 is divisible by 3. So the cube root of y cubed is just y, because y times y times y is y cubed. And I can also simplify the cube root of 8. That's just 2. So I get 2 times the cube root of 4 times the cube root of x times y, right? I cannot simplify the cube root of 4 any further. I cannot simplify the cube root of x any further. But I know, using a product rule, I can write this as 1 cube root. And I'm going to go ahead and put the 2y together. So I'm going to put the cube root on the end. So it's going to be 2y times the cube root of 4x. So that's going to go here. So 2y times the cube root of 4x. Plus, okay, let's talk about the cube root of 108x. So I'm going to do that. Let me do that here. All right, so the cube root of 108x is the cube root of 108 times the cube root of x. All right, so let's think about a perfect cube that goes into 8. Let's try 8 again. Let's see if 108 is divisible by 8. So 108 divided by 8, it is not. I got a decimal. All right, so the next perfect cube is 64, right? So let's see if 108 is divisible by 64. You're going to see it's not. You get that, correct? All right, so then you go through the process, and notice I started with 8, 2 cubed, and then I forgot about 3 cubed. So 3 cubes 27. I forgot about that. So 108 divided by 27 gives us 4. So 27 is the largest perfect cube. So this becomes a cube root of 27 times a cube root of 4, right? Times the cube root of x. And I know the cube root of 27 is 3. I cannot simplify the cube root of 4, nor can I simplify the cube root of x. But I do know I can write this as 1 cube root. So that's be 3 times the cube root of 4x. And that's going to go here. But remember, that's being multiplied by y. So I get y times 3 cube root of 4x. Okay? Now I'm going to go ahead and rewrite y times 3 as 3y. So I'm going to get 2y cube root of 4x plus 3y cube root of 4x. Now, those are like terms, and you got to understand the reason they're like terms is not just because of that cube root of 4x. Okay? So whenever you have some extra variables involved outside of the radical, you got to consider those also. So notice I have y to the first and a y to the first. So I have y cube root of 4x and another term with y cube root of 4x. So those are like terms. I have 2 here and a positive 3 here, so I have 5 altogether. So I have 5y cube root of 4x. And there's your answer. All right. So that is the key to the worksheet, topic 21, part C, radicals, extra 11.